Okay, this is Unit 1, Section 1.4. We're still looking at experimental design. This is our second day. So, again, our goal here is kind of connecting these ideas. We talked about some components of an experiment as far as the explanatory and response. Now we're going to look at the well-designed experiments, also looking at some designs and methods that we're going to use. Our goal, in addition to that, is also to explain why experimental design is appropriate. So our vocab for today, we have treatment, which is a specific condition applied to the individuals in an experiment. And if there are several explanatory variables, the treatment is a combination of them. So treatments are what we say we have control over. That's what we're imposing upon our individuals in the experiment. The experimental units or the subjects are what we or who or what we're deliberately imposing some treatment on. We call them subjects if they are human, experimental units if they are not. Apparently people didn't like being called experimental units, so we call them subjects of an experiment. Random assignment, so this is where we have our random assignment that comes back in where we randomized out of our population to create our sample when we were looking at surveys. Now the random part comes is we want to use our experimental units and assign them by chance the treatments that they're going to get. So we don't want our individuals or experimental units, we don't want them to be able to choose the treatment. Our goal is to have a completely randomized design. This is our first experimental design or method, and this is when the treatments are assigned completely by chance. So we haven't grouped them, we haven't paired people up, and we haven't had them do it twice. This is going to just be completely randomized where we say, okay, here's our group of individuals that are ready for the experiment. We split them up, assign them treatments, and look at the results. Our last vocab is a control group, and this might be something that we would include in a completely randomized design. And this is an experimental unit that doesn't have a treatment applied to provide a baseline for comparing the effects of other treatments. So we might have, treatment 1 is the old medicine, treatment 2 is the new medicine. And so we might have an experiment that sets this up where we have, 60 individuals and 30 are here and 30 are here. We want to compare whatever we're trying to reduce, headaches, something like that. We could also include a control that says, okay, do we need this medicine at all? And instead of 30, do 20, 20, and 20, and use a control to see maybe it doesn't have anything to do with the medicine at all, whether it's the old medicine or the new medicine. Just completely staying away from the medicine is actually what's controlling that reduction in headaches. So a control group is something that we might include as one of the treatments in part, but it also has no treatment applied to it. So in our example, it says, many utility companies include programs to encourage energy conservation among their customers. An electric company in San Diego considers placing small digital displays in households to show current electricity use and what the cost would be if this continued for a month. One cheaper approach is to give customers a chart and information about monitoring their electricity use from outside their meter. Outline a completely randomized design experiment that will test the effectiveness of these methods of influencing energy conservation on 60 volunteer single-family residencies. All right, personally, I get like an email or a piece of mail every month that tells me how I'm doing compared to my other neighbors, and I'm super judgy, but I love it, where I'm like, yes, I'm being super energy efficient. Okay, and I keep my air conditioner like cold. Like I stay cold all year round. So air conditioner, high. Our heat bill, low. So I think that's funny how this is going. So if we wanted to do a completely randomized design, here's kind of what I was thinking. We would number each home 0, 1 to 60. Okay, and this is where we need to go back to our label idea and then randomize. So we're going to label so that all 60 houses have a number. Use a random number generator. And I did 0, 1 to 60 because I didn't indicate whether this was going to be my calculator or the random digit table. But I'm going to use that to select 30 homes to put into one group, and then the remaining 30 homes into another group. Okay, so that's going to be my first thing, is to take all 60 and split them into 2 groups. Next, our first group will be assigned either heads, digital displays, or tails, the chart. And we're going to determine that with a toss of a coin. Again, my first group doesn't get to choose which one they're doing, and I don't want to choose it for them either. I'm going to let that be randomized as well. The second group will be assigned the other treatment. Have both groups use their assigned monitoring method for 6 months and then compare the results. Okay, here's one way that we can write it out, where this is going to be kind of the written way. We can do an outline that is more visual as well, where we'd have 60 households, and we're going to randomly assign 30, and we have the remaining become this other group of 30. So this is kind of outlining that idea. Use a random number generator to get 30. Remaining 30 go to here. We're going to random this first treatment, and the remaining get the second treatment. And overall, we compare. Okay, so we compare the results. And so in our case, the results are going to be, have we actually influenced that energy conservation? So how did the 2 groups do? Should we actually invest in getting small digital displays in every household? Or was it just as effective to give them a chart and information about monitoring their own use from their outside meter? All right, so I want us to next watch this video